Okay, hello, good afternoon. Welcome to the fourth tutorial in ICEGOV 2011. This is going to be about the cloud. It'll be following on in some ways from the discussion on interoperability and EID this morning. So if you're still burning to ask a question about that, you can wait for the question session in this one. We're aiming to leave 30 minutes at the end for questions. And as before, if you do want to tweet a question on #ICEGOV, then that improves the odds of me reading it out or getting you to ask it. Okay, we're going to kick off with John Savageau. I've always called you John in our conversations. John Savageau? Savageau?
Pretty close.
Okay, who has suggested that we don't use more than 3 words to introduce everybody. And I cheekily said, so I'll introduce you as single point of failure. Whether this is fair or not will become apparent during his talk, although you can also read his bio in the program. John.
Oh, thank you. Oh, my title slide seems to have found a new home, but thank you. Today, the objective that I have and we have as a group is to bring everybody in, and by the end of the session, everybody will be able to at least be able to talk and understand the basic building blocks of cloud computing and some of the implications that has with e-government and government systems. Myself, I come from the area of building data centers and having supported quite a few cloud computing companies in the early days and in the later stages of what are in the commercial public cloud sector, and have quite a bit of experience in the good and the bad of cloud computing. But to set up the conversation, I'm going to touch on 2 topics. The first is data center consolidation, and the second is disaster recovery and business continuity, as 2 areas that have really driven cloud computing into both the public and private sectors. I'll go on to do a basic intro to cloud computing 101 course, briefly introduce a Moldova case study of what we've done, and Mr. Turcanu will follow up with a more detailed discussion on Moldova, and finally touch on a few government roles in cloud computing. And to start it off, a lot of things happen day to day when you're in the technology business. And myself, I'm an engineer, so I focus on slightly different things than policy. But things that happen to me day to day is I have to consider the data centers that we operate today, whether they're efficient, whether they're not green, they're wasting money, geographically untenable, business continuity and disaster recovery issues. And what's really driving a lot of the cloud computing discussion is that now we're really entering a technology refresh cycle for some of the systems that we've had for 5, 10, or 15 years, and now those systems are no longer supportable. And marrying that, or connecting that, to the idea that applications on cloud computing and virtualized systems are really creating a new enabling platform that governments and private industry can use. It's a very interesting dynamic that's happening today. But I'm going to start off and talk about the need for consolidating data centers as one step in the road to cloud computing. Even in the US, where I'm from, a year and a half ago, we came up with this idea that we had more than 1,100 data centers supporting only the central government in the US. A lot of those were server closets, a lot of those were not really documented very well, but the US government said, we really have to take a look at how much money we're spending to support more than 1,000 data centers for every little agency the government has, and find a way to consolidate that into 12 or 18 or less than 20 data centers and make more efficient use of data, as well as be able to implement greener technologies and much more efficiency. Not just the US government, the Australian government also. They have now a vision that all of those individual data centers, servers under desktops, server closets, really they should be embraced into a whole of government idea of how do we actually handle data and how do we actually handle applications within the government. And the idea, again, that we're in a technology refresh cycle. Technology is changing very quickly, and the software that rides on that technology is changing very quickly. And the idea of consolidating data centers makes a whole lot of sense. When we look at a traditional data center that an individual office or agency has versus a consolidated data center, there's some things that really stand out that we'll talk about a lot more in a few minutes. For example, the average utilization of an IT infrastructure in a single traditional data center is somewhat way less than 20%. For example, everybody's laptop computers, desktop computers, servers, shared storage devices. If you look at what you have on your own computer, you probably have a 500 gigabyte hard drive, and you're probably using 100 gigs of that unless you store a lot of movies and things like that. Well, that's actually a lot of cost from taxpayer money that's going in to buy all that excess capacity. And now we're looking at how we can recover some of that capital expense and return it to productive use. And when we went into, and this is actually the first slide of what we did in Moldova. When we first went into Moldova and looked at what we could do to create a more efficient environment in Moldova, the first thing that I did was I started doing surveys of every government ministry, agency that would allow me in the door, as well as most of the private sector within Moldova. And we found a lot of really interesting things, like very little of the infrastructure was actually using modern, sustainable hardware and sustainable software. We actually had quite a few agencies that had live government data that were running on old PCs that were on a desk, had absolutely no storage or backup devices, and were running old software like 1990s versions of Fox Pro for databases. Obviously, that's not going to meet the needs of the 21st century. But really, the two things that stand out are, what are you going to do if one of those old PCs crashes a hard drive and there's no backups? This is another country, actually Indonesia, where I did a similar study and went through, I guess it was probably 45 different agencies in Indonesia, and we were rating, in my judgment, and definitely a subjective judgment based on my data center experience, and very few agencies within Indonesia actually came up with what I would call an acceptable standard of supporting their data or supporting their operations. In fact, the only one, if you see the green there, the only one that actually I gave a passing score was a private company. All of the government agencies, with the exception of the Ministry of Finance, actually received overall marginal or something less than acceptable scores. But not all IT managers in those organizations were very happy about the idea of potentially losing their server closet or losing control over their data. And it's not just confined to Indonesia or Moldova or any other country that's in the developing world. This is a survey that was taken by a US organization called the National Association of State Chief Information Officers. And in the US, IT managers also aggressively resist anything that has to do with consolidating and losing power over their data centers. In fact, the most common response to why an IT manager or why an agency would not consider consolidating their data centers and data into a centralized location is that they just don't want to change. They want to remain autonomous. They do not want to give up their internal processes and how they do things, and they don't like transparency. Pretty much the same in every country that we've looked at. The second big area, talking about the surveys that we did is, of course, disaster management. And disasters do happen. And I'll give a couple of examples. This is not a government example. This is a large telecom facility in Seattle, Fisher Plaza. 3 years ago, they had a bus duct, an electrical bus duct explode, and took the facility out for about 2 weeks. Very large companies using that, content distribution networks, telecommunications companies, all of those all of those people using Fisher Plaza they were just completely out of the network for about 2 weeks. This picture here that shows a fairly well damaged, disintegrated bus duct is in my own facility, which was One Wilshire in Los Angeles, which many people believe is the most densely interconnected telecom facility in the world. We had a 4,000 amp bus duct explode right next to the meet me room where more than 400 carriers interconnect. Disasters do happen, you have to plan for it. Fortunately, our backup systems all operated and the world never knew it happened, but in a disaster like either one of these, global communications could have been set back quite a few years. And there are a lot of directives that help us with disaster recovery planning. But the whole idea of how we're operating data centers means that if we're responsible for data that belongs to the people of the country that we're paid to support, we have to be able to protect that data. So the main objectives of the disaster recovery plan with the data center consolidation plan, and as we talk about how this fits into cloud computing, is how do we safeguard the data that we're responsible for? When a disaster happens, not if, but when the disaster happens, how quickly can we respond and how quickly can we restore operations? And as we continue talking about cloud computing, policies, and standards, we'll try to find answers to those questions. So now's the fun part for me. As an engineer, as a technology person, I love cloud computing. It is just, it's a great thing, but it's actually not just for geeks. It's actually a very important thing. A lot of people believe, including those in my own government, that it's one of those items where you can run but you can't hide. It's like internet email. In 1990 and 1985, if you had a business card that had an email address on it, people would look at you like you were nuts. Why don't you just put a fax number on there? Why are you messing around with this email stuff? Things will change. Time develops ideas and time develops technologies, and cloud computing is going to happen. But we have to start preparing for it, and with any technology refresh or any point in an innovation cycle that things are changing very rapidly, there will be trouble of standardization, and there will be a requirement to plan for that. There's a lot of different definitions for cloud computing. If you put your name on one of these definitions, you will find people who will object to that and will find a reason to say that's not the right definition. But most people in the US now and many other countries are actually following the NIST, which is the US National Institute for Standardization and Technology. They're starting to follow the NIST guidelines because that really is the only national guideline that has been put out into the cloud industry, and the rest of the world appears to be following that as well. And as we continue getting ready to think about cloud computing, today, and this is from various sources, I collect data a lot and put this graph together. Generally, about 53% of the cost of IT is in hardware, data centers, and something that actually does not manipulate ones and zeros. About 11% of that is in applications development or setting up new applications, and the rest of the 36% is in maintenance of existing systems. Our intent with cloud computing is to begin relieving IT managers and organizations of the burden of maintaining hardware, facilities, and other pieces of equipment that do not actually directly contribute to the operation of your organization or company. And we talked about Above the Clouds, the Berkeley study a while back. This is actually from Above the Clouds, where Berkeley had, this is a very good graphic where they will say that, and again, I was talking about your desktop computer that may have a 500 gigabyte hard drive, you're using 100 gigs of it. Well, overall IT follows that same kind of concept where we actually have to buy and plan our equipment to meet peaks in our demand and usage. So if this top of the bell represents a peak of IT systems demand, us as an organization, we have to buy capacity or provide capacity that always exceeds that demand. Whereas we start talking about cloud computing, our objective is to only have a requirement to use capacity and acquire capacity that matches our demand cycle. And to put this in another graphic, let's say if in our organization we have 5 different agencies, and those 5 different agencies all buy similar IT systems with the same amount of capacity, it's likely that none of those agencies are going to use all of the capacity that they've bought. So thus, you're still operating 5 systems, facilities, electricity, air conditioning, people, all those things that are required to drive these facilities, when in reality, when we start talking about virtualization and being able to pool resources together and allocate those based on need, we may be able to eliminate, in this case, in this representation, 60% of what our overall capacity is. That's the objective. So the next few slides are a little bit wordy, and I will back those up with graphics in a couple of moments. But these are words that you're going to continually hear in any discussion on cloud computing. And again, these are terms that are provided by the NIST, or the National Institute of Standards and Technology in the US, but have been broadly adopted around the world. And those characteristics that we're going to look at to be able to match demand and IT capacity are the ability to have on-demand service. Everything that we do today runs on a network, so we have to be able to provide broadband and be able to provide that to users as well as to connect machines together. We want to be able to take resources, multiple individual resources, and make them look like a single resource. We want to be able to have access to compute and storage capacity when we need it and give it back when we don't need it anymore. And we want to be able to bill for it internally, as a cost center, or if you're providing it as a private or a public cloud service, you want to be able to get paid for the service that you're offering. These are probably the 3 most common terms that you'll see when we're talking about cloud computing, and it starts kind of building the infrastructure from the ground up. We talk about infrastructure as a service. In very simple terms, that means being able to virtualize hardware resources where, for example, you may be able to take 100 individual servers, and to the infrastructure as a service, it looks like a single resource. So instead of having a 1 gigahertz processor, now you have a 100 gigahertz resource. And the same thing applies to storage and other things. Platform as a service, in the most simplest terms, is when you're able to take that virtual pool of resource and put operating systems on top of that to be able to build what I'll call a virtual data center capacity. And on top of that, we have finally software as a service, which is what the user eventually will access. If you're familiar with Gmail or Yahoo Mail or Google Apps, that would be classified as software as a service. NAST has broken down several different cloud deployment models, and we've recently added a 5th deployment model. But at the most basic, a single organization that does not want to share resources with other organizations, but does want to be able to create a single resource pool for their own organization, would use what we call a private cloud. It means that it's a cloud resource, but it doesn't actually share that resource with other users outside of the organization. A public cloud is something that you go and buy. You can take your credit card and go to Amazon or Microsoft or Google or Layered Technologies or somebody like that and buy compute capacity. That's a public cloud. A hybrid cloud is when you have a private cloud, but you want to also be able to access additional compute and storage resources if your requirement or application requires you to go outside of the boundary or the threshold or limits that your private cloud has. A community cloud is when you have several different organizations that have a similar mission or a similar way of doing business, and you want to be able to share resources within that community so you can connect different clouds together that share a single common goal, and we'll call that a community cloud. And the final is what we'll call an intercloud, which doesn't exist today, but we're trying through standards to be able to standardize the infrastructure and platform as a service, which would allow full interoperability and portability between cloud vendors and manufacturers, or cloud vendors specifically. And if we put that all together, this is one way to look at it. So you have the characteristics that are common to all clouds. You have essential characteristics, service models, and then some cute clouds on top that give us an idea of individual private, community, and public clouds, and then connecting them all together into a hybrid. The next several slides will hopefully graphically represent what I just gave you in the architecture and the framework, so it'll be a little easier to visualize. As an engineer, I kind of live on a whiteboard, so visual support is important to me. But if we look at all these cabinets here, I'll say these are all processors. It may be blade servers, it may be a bunch of individual small servers, but our intent is to take 100 servers and to the resource make it look like a single resource that can be allocated as we need. The same thing applies to storage. Instead of having a 1 terabyte storage array, now I'm going to put 1,000 of them in there, and now I have a petabyte resource, a single petabyte resource that I can allocate as needed. I need to be able to manage that. On top of that, I need to be able to build operating systems and build environments. On top of that, I need to be able to prepare individual applications and present that to end users. And here's a graphic representation of how you might be able to do that. So, and this is some friends of mine at a company called 3Terra provided this to me. If I look at this stack, we'll consider today that everything behind this is what we'll call infrastructure as a service. So behind this, I have all this mess back here. So I have this huge compute resource, a huge storage resource, and it's managed. The next thing I want to do is to create objects. I want to be able to create operating systems. I want to be able to create virtual switches, routers, firewalls, servers, all that type of stuff. And I build those in objects that the infrastructure as a service will be able to identify. So I need to have a couple of Linux boxes. I need 3 Linux boxes. I can go up there and grab a Linux icon, plop it down into this board, put in some characteristics of how many CPUs I want, how much memory I want, what kind of bandwidth I think it's going to need. I can set up all those attributes and plop those 3 servers down, and the platform as a service function will create those servers within the infrastructure as a service pool of resources. If I want operating systems, I'll go back and say, well, I want these to be Linux boxes. Make sure it's Linux. I want a switch. I can say, okay, this is a virtual representation of a 12-port switch. I'll drag that switch in there and plop it in there and take lines and connect the servers to that switch. I'll put a router up here, connect the switch to the router, face that into a network. If I need to, I will start putting database images on top of those servers. And that's what platform as a service will allow me to do. All in a matter of, if you know what you're doing, just a matter of a few minutes. What you have done is created a virtual data center. So rather than having 100 square meters of, let's say, 150 kilowatts per square foot, or 1,200 kilowatt or 1,200 watts per square meter, and having people that are required to go in and put servers in, worry about hard drives failing. Now the IT manager just needs to know what he really needs as a data center. He takes those objects, makes sure he has enough capacity, and creates himself a data center. And to the end user, it doesn't look like anything other than now I know the IP address of a server. In fact, all of this is connected both with IPv4 and IPv6, if you're familiar with the internet routing protocols, and looks like a virtual Ethernet connection. Another graphic representation of that, where here is your infrastructure as a service. and we're creating virtual data centers on top of that in a single facility rather than 20 or 30 facilities. Management, I need to know out of all that infrastructure how much I'm using. I need to be able to meter it and plan for it. And for the end user might see that as a Microsoft Office 365. It might be a Google Doc, could be Yahoo Mail, could be a WordPress blog. The end user really doesn't care. They don't care whether it's coming off of a physical server or whether it's been created within a virtual cloud. To the end user, all they want to use is their application. What we consider one of the most powerful applications today is virtual desktops. Again, the same thing that applies for servers, where you're not using much of the capacity as a server, also applies to individual workstations and laptop computers. The reality is today that we use workstations and laptop computers because we want them, not because we need them. All of the applications that you can do on your laptop computer, with the exception of some graphics programs, CAD, Visio, things like that, you can pretty much do off of a virtual desktop. And that, I would submit, is probably 90% of everybody in a government organization is using email, word processing, presentation software, spreadsheets. And if that comes off of a central cloud-based system, they would never know the difference. So to start wrapping up the first part of the cloud discussion, NAST also has additional priorities to add on to that great cloud infrastructure. It's interoperability, portability, and security. So while cloud is a great thing, it's as you continue to think about it and study about it and start seeing it implemented within your own countries and organizations, there are still three items there: interoperability and portability and security, that have not been solved yet and still needs work. A final representation when we're talking about disaster recovery, and again, this is in the context of Moldova that we created this model, is that with clouds and having adequate broadband access between a primary and a backup data center, we are able to easily store an image of all applications that are contained in the primary data center, and we're able to image or create backup images of data that's created within the cloud system through the network. In this case, we're showing that as an incremental change or a mirroring change in data, we're actually just changing data that's been modified instead of recreating files. And the ability to reduce a recovery point and a recovery time to near zero. We believe that when this architecture is implemented, it will meet the needs of the government, and if the government has a catastrophic failure, that we will be able to restart the government with very little pain. The next section, two more sections of my presentation, are some issues and concerns. We talked about portability and interoperability, and that will be also discussed a little further later, and it's actually, I think 3 sessions within the ICEGOV conference are on interoperability and portability. But we're going to talk more today to open up the discussion on security, which will be discussed further later in today's presentation. With clouds, while we believe as an industry, as engineers and technicians, that cloud is secure and is safe, you're putting a lot of trust in us as engineers that we're actually protecting data at the same level that we claim we are. Of all the issues with cloud computing that government IT managers have, security today is by far the biggest concern. A lot of things: portability, implementation costs, flexibility, customization, availability, and performance. They're all a lot less of an issue than security is. And particularly with privacy data, what we're going to do with remnants. If the elasticity of cloud allows us to grab capacity when we need it and give it back when we don't need it, what happens to the data that's in that area that's been given back? So there's a lot of issues that we're dealing with, with data remnants and, how we're going to manage privacy, the geographic location of data. In a country like the US, it's not as big a deal because it's a big country, and within the country we have lots of data centers. In smaller countries, it may not be as easy to handle if you have disaster recovery and backup requirements. But those are all issues that we'll talk about more as the presentations go along. Probably of all the issues that we have with government, as we start getting into this technology refresh cycle that will pretty much induce the public and private sectors into considering virtualization or cloud computing, probably the biggest role that governments have is in the idea of thought leadership. And we'll talk about this in the context of Moldova a little bit further, but when we first went to Moldova to look at the country and see what it would take to implement a cloud platform, the first thing we realized is that very few people within the country were actually familiar with cloud to the point where we could discuss it on a policy basis or discuss it on a future development basis. So the first several months that I spent working in Moldova was more of a teaching exercise where we had to actually bring people up to the knowledge level that was required before we could actually seriously engage in discussions of what cloud computing might be able to do for the country. And once we got to that threshold, the discussion was very easy. And all of those resistors that initially told us, no way will our agency even consider virtualization or cloud computing, after we completed that education process, most of those arguments started going away. The government has to make that vision available, not only internally, but also, to the public sector. And another thing that I'm not going to talk about in detail today, but when you start talking about reducing, again, 1,300 data centers into 20 data centers, the impact on the environment and how much electricity you're using and how much water that you're using, all of those impacts are huge. And, environmentally, cloud computing also makes a whole lot of sense, but I won't read these one by one. It's easy enough to see, but it's really the vision is to create a secure government computing pool of resources and to drive government agencies into using that and to feel comfortable in using those pooled resources. Getting back into the preparation for the Moldova discussion, after we were able to complete the thought leadership process, the next major phase that we had to go into was to actually create statistical data and create real survey data to show exactly where we were today, what the risks, what the opportunities were to consider cloud computing, what it would take organizationally and knowledge-wise, not only in the universities, but in the public sector and the government, what it would take to bring everybody up to the point where we could actually then make an intelligent decision on how to go forward. And that cloud readiness assessment, I believe, was one of the more useful tools that we had. And if you're interested in that, ask me later, or Oleg Petrov from the World Bank is going to be here shortly. You can ask him since he's pretty much driving that. But Moldova was interesting. Moldova, again, a recently democratized country. A lot of legacy systems in place, a lot of very well-educated, smart people in an economy that's begging for a way to get moving, and a government that's looking and trying to find the best way to create an environment to allow that to happen. So when we started talking with Moldova, and mCloud, by the way, stands for Moldova Cloud, the requirement was to try to get all of those old legacy high-risk systems, eliminate those, and to try to create a government-wide shared pool resource that any agency in the government, whether it's central, whether it's the Rayon, or whether it's the local level in the country, would be able to take advantage of those resources if they wanted to. We looked at all of what we've talked about today, the business continuity, disaster recovery surveys. We did a very detailed cloud readiness assessment. I interviewed probably every IT manager in the ministries and most of the commercial or public companies in Moldova, and codified all that into a very good feasibility study for the country, which is now being executed, which Mr. Turkanu will explain in a moment. And we're at this line right here, right now. mCloud is now out for bid. The leadership is fully engaged on cloud computing within Moldova. We were able to build what we'll call a cloud-first policy, which means that now during technology refresh cycles, or when individual ministries or agencies are going to need to increase their IT capacity, prior to approval of acquiring equipment or IT or software to do that, you will have to pass a question of, can you do this in mCloud? And if you cannot do that in mCloud, then you have to create a justification of why you will not use cloud computing for that specific application, hardware purchase, or system that you want to establish. And if you look at a graphic representation of what mCloud is going to look like, again, a central data center where we have compute, storage, communications, all of the resources that you would have in all of the different ministries that are there today, but in a single location. Riding on top of that, quite a few different applications that come from an application store that is being built for mCloud, meaning that if you need a Linux image, you can get a Linux image. If you need to create a VoIP or an IP PBX, we can drop an IP PBX into mCloud and create a telephone system. Connecting that through communication systems that are available to all points in Moldova today, whether it's fixed line or wireless that touches all parts of the country, not only for government users on a dedicated access, but also through internet networks for citizen services and for remote users. So we believe that using Moldova and Indonesia and Vietnam and other countries that we've worked in on similar topics, we believe that there is no reason not to start considering cloud services in a country or a public business. Even if it's small pilot projects to take advantage of disaster recovery or take advantage of shared email systems or simple systems, there's no reason not to consider using cloud today, because as a technology, we believe it is going to be the future. Everybody believes that cloud computing and shared resources will be part of the future. Just a couple more slides and I'm done. We need standards. We need to provide, as governments, not only standards for our own internal users, but also to provide guidance to the industry. We don't want to make everything a standard. We want to have a standardized core set of services that allow interoperability and portability of data, but we also want to encourage innovation that allows software companies and IT managers and people to be able to use the core capacity of a cloud system and to create new and better things, and continue with the technology development cycles. There are a lot of standards. It's going to be very confusing. Everybody is now trying to develop a cloud standard. Most of us still follow the NIST or the NIST guidance. NIST is trying to get their arms around all of these different standards and put it into a single place that software vendors and hardware vendors and other people can use, as well as users. But it's going to take time. The internet today, if I could be so bold as to say, if you ask everybody in this room to tell you what the internet standard is, that we'll probably get 100 different answers. So even the internet today is not 100% standardized. NIST has also tried to create a picture that's called a reference architecture, putting all of those things that we talked about today, the service layers, how you put it together, security, privacy, what will happen when we try to look at hybrid clouds and community clouds and things like that. we're trying to put those into reference architectures that will change over time because technology and innovation, everything changes over time. But we're now trying to put that into a picture that we can all understand. And this is again subjective just on my part as the final slide. I believe we're right here. We haven't got to the point where we are able to open our clouds up into interconnect clouds where we have true interoperability. Realistically, I think that we're right here, somewhere between private clouds and being able to go out into a hybrid. And with that, I will pass on the baton.
Thank you, John.
Sure.
Fantastic. Okay. An unexpected slight delay, but I wonder, John, do you fancy taking a question while we wait for this? Let's not waste this moment. Does anybody have a surprise question? Hang on.
I have Georgi from Georgia.
Yes.
It is considered any offline mode for this cloud computing. Offline mode.
I'm sorry?
It is considered offline mode for the cloud computing.
Offline.
Yeah. In case of service not availability and so on.
An offline mode for cloud computing?
Yes. No. In this model, very important is connection. Yes.
Mm-hmm.
If
Oh yes. Yeah, I mean.
in some cases, maybe the connection interrupted, and in this case, maybe client should have the ability to, I don't know, offline operation and so on.
Yeah, and with cloud computing, I mean, today, again, we're not to the point where all of us will have connections 24 hours a day, all the time, regardless of where we are. So today, if you're accessing a system that's, let's say, an e-government system, the intention is not to have that as an offline system. The intention is to have remote access to a centralized application. But if we're talking about a desktop application,
No.
where you need a word processing document,
Yeah, some case.
and today, as we sit here, all systems that create VDI documents allow you to store an image of that document on a local computer. All of them that I've used anyway. Sorry if that helped.
No, it did. I think it was very relevant. Thank you. That's so. Our second speaker, Fransesco Garcia Moran, from the EC.
Okay. Thank you very much. So, based on the speech by John, I found very good as a tutorial. I'm going to tell you a little bit. Mike is here. I have to switch it on. Okay. Now? No, it doesn't work. Okay. Okay, perfect. So I wanted to go through what we call the European Cloud Computing Strategy, if any, that is included as one of the actions in the European Digital Agenda I spoke about this morning while presenting the interoperability and EID from the European perspective. So, on the definition of clouds, there was a group created by Director General for Information Society of experts in cloud. And they came up with a definition, and this is the problem of the definitions. First of all, there are too many, and the second is that some of them you don't even understand. So they came up with that, and when creating the slide, we discovered that it didn't mean a lot for people for the normal people. So was tough, so I decided that the best one was the one that was used by John before, coming from NIST. So it's the model, and it's the on-demand, it's a shared pool of resources, and all the blah, 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 blah that is around that. But my problem was that my commissioner, who is a politician, diplomatic background, in charge of IT, said to me, well, okay, explain that to me. And even with those definitions, things were tough. So I decided to make a joke. And I did this one. So you are in the clouds when it rains. When it's not raining, you are in the sun, and you have both. You have the rainbow. The guy didn't understand the word, but we had a lot of laugh together. So just to say to you that selling the cloud to the politicians with that name and everything that is behind is not a simple thing. Okay, right. So I stop joking over here and I go for very serious issues. First of all, we really believe that the cloud is going to progress. And this is what the major kind of consultancy companies see about the cloud in the future and the distribution based on the kind of cloud services you can expect, and were very well presented by John a few minutes ago. So yes, even for 2012, there is a lot of millions in the game over there, and people are pushing a lot so that public administration and the private sector are going for the cloud as soon as possible, because we need business to make Europe grow. So, in the digital agenda, is said clearly that we should develop an European-wide strategy on cloud computing for government and science. And we were pretty restricted there. Quite a challenge itself. As a matter of fact, one of the questions that we ask ourselves is, do we need any kind of European-wide strategy on cloud at all? And this is what we are going to discover in the coming months. We have a number of challenges. Some of them have already been mentioned by John a few minutes ago. I was in a meeting on the first week of September, together with other director generals, and I'm going to give you the landscape of people that were there. Director General for Justice, about data privacy and data protection. Home Affairs, about law enforcement. Industry, because of small and medium enterprises at cloud suppliers or cloud consumers. They were the people in charge in enterprise, in charge of standards. They were my Director General in charge of interoperability and many others. It means that cloud have a lot of things to study before we go full strength. So that will be gradual. Second thing is that there is a mystery in this issue of the cloud. There are a number of new things that have appeared, basically with virtualization, with broadband available everywhere, high speed, with the movement to data center consolidation. But all that is on top of something that already existed for some time, is outsourcing. So there are a few cloud examples, mostly public clouds, but it's not new. Nothing is new over here. It's an incremental progress like any other things. You remember that when the web, the www was born, internet already existed for nearly 20 years. So we didn't discover anything. We just found the paradigm that made it explode. So on interoperability, it's essential. It's going to take time. It's going to cost a lot of effort. It's going to cause a lot of discussion, but it's essential if we want to have choice. And interoperability is here for choice. And data portability is one of the major preoccupations. Today, in reading on the internet the news, on the Spanish newspapers, I read a news that said the French government is going to invest 138 million on creating their own cloud. Why? With the participation of the private sector, because data portability is no thanks. So this is the picture as is seen by the government. I was presenting this kind of ideas in one meeting in Spain in February this year. Everybody spoke about virtualization. Nobody spoke about except for very exceptional services such as public dissemination, information dissemination, about implementing public clouds into the government. A lot of people spoke about private clouds. So, I mean, there is a fear there that is important. Standardization. It's already complex in general. Imagine for something that is completely new, that is even behind the scenes. Those who thought that the captivity or the lock-in was concentrating on office automation products or database products, now what you see behind you don't know what is it. So the locking has increased one layer, and this is very important. The locking is much more important if not taken into account with appropriate standards. The supply side, no thanks. don't mix up with my business. I want to get my customers forever. The demand side is difficult. When are we going to start with that? How do we start at all? And there are plenty of involved parties. The industry, the government, all the standardization bodies, official or industry-driven, that you find around, plenty of issues. There are regulatory requirements that we are still preparing. And the fight between the fora is important, like in any other kind of approach to standards. So, good understanding, essential. This data migration issue is important, but at the same time is the basis for economics. If you look at the cloud elasticity, what global cloud providers are doing is transferring the workload from one zone to the other as you go to valley or to peak. And this is the way they work. If we are asking for non-data migration, that's going to have an influence on the price. No doubt about it, and we need to accept it if we want it. Apart from that, I mean, legislation is completely different at the European level, not to mention at worldwide level. So, we need to create a legal framework, and we are starting on that. What is at stake? I really recommend you are interested in cloud computing and more particularly into the security area. I am member of the management board of an European agency called ENISA. That stands for European Network and Information Security Agency. The guys have prepared a number of reports that are public on the internet, enisa.europa.eu, and I really recommend them because they are pretty good on the challenges on the cloud for the government and for the citizens. We have an informal group of CIOs at the European level. And we meet back-to-back with some of the meetings for our programs, either the e-government group at European level or the ISA steering committee. So we asked them what do they think, how they would approach the cloud. So at the time it was March 2010, if I remember well, or April, 25% of the countries had national strategies. Not too bad. 50% that are using already are for public services, and 43% are planning. And you see the challenges and the benefits are pretty much in line with the fears and the threats that were mentioned in John's presentation. So nothing new on the horizon. Everybody is thinking and pulling the hair. So if ever we have an European cloud strategy, we need to see the market, the legal framework, and the technical and commercial issues together. And this is the intersection, what is important on all that. So what are the ongoing activities? So the data protection framework will be revised. There will be a proposal from the Commission, the revision, before the end of the year. And this is a hot topic. If we fail there, we may either facilitate or we may really prevent the cloud from being a reality in Europe. We need to reform the standardization system and give more voice to the industry. And we need to better use those standards that are going to come in public procurement so that we really make them applicable. And of course, issues are related to network security. There is a new regulation for ENISA that contains fight against cybercrime. That is one of the issues that are of the highest preoccupation for governments. And then, believe it or not, the European Commission, through the Research Framework Program, has been funding research on cloud already for the last 3 to 4 years. And there is a lot. There you have a few of them, but I'm going to show you more and the amounts involved. You have two major programs that are funding those kind of research. One is, as I said, the 7th framework program for research, On the calls for 2011, 2012, you have already calls related to research calls related to cloud, and also on the competitiveness and innovation program, we have already launched to the attention of our member states kind of cloud projects with 50% participation of European funding. We have a number of challenges in the future. And some of them I'm not going to repeat them because this is pretty much in line with what was presented during the tutorial. So we have the Internet of Services and we have advanced software engineering that are going to contribute to the progress of the cloud. The cloud is at the beginning of the technology. We have virtualization, we have elasticity, there are plenty of software paradigms that are necessary in order to make the cloud something that is ideal for the services. And we have a number of support actions, of course. So those are, very quickly, some of the projects that are being funded, some of the projects. And you see there that if you count the existing and the starting projects, we are already funding with more than 88 million euros. Kind of cloud-related research, including, of course, what is essential in the cloud, service-oriented architectures. So if you want more information, you can go to the different websites of the projects, and there is full of documents and ideas, and some of them are really pretty interesting. So what you have to take away from this European approach or landscape is that it's changing the ICT market, no doubt about it. We need to become cloud-friendly and cloud active if we really want to play it at the European level kind of role into the globalization. We need to have international policies needed, not only in Europe, but also elsewhere. And we are working on the regulatory framework, and our plan for the time being is to try and present a strategy for the cloud in February. In the meantime, DG Information Society, the Director General for Information Society, launched a public consultation that has been pretty successful. About 600 replies, some of them very extensive, to the consultation. We are now analyzing the replies, and we are going to come up with some kind of report with the summary of what we found there. And that's it. Thank you very much.
Thank you. Am I on? Thank you very much. Okay, so Yuri, I think you're next.
Sorry.
Wonderful timekeeping too.
Thank you. Yeah, I hope.
Yeah, so ladies and gentlemen, good afternoon. In the following minutes, I will try to present you the initiatives of our government for modernization of our infrastructure. And since we are talking today about cloud computing, we have this technology at the heart of our environment, of our infrastructure. But first of all, let me satisfy the curiosity of some of you regarding where Moldova is and what infrastructure it has. Is it ready for the cloud computing at all or not? So Moldova is a very small country at the southeast of Europe, and we are neighboring with Ukraine, and we are neighboring with Romania. The area is 33,000 square kilometers, and the population is about 3.5 million. So it's, as I said, it's a small country, but we have quite good achievements in wiring the country. We have a fiber network connection to each of the locality of our country, and the internet penetration is moderate, is 42%. At the same time, the mobile penetration is quite high. The last month it was about 92%. So we have, as any of governments of your countries as well, we have some objectives which derive from our country development program. And our government set up different objectives related, deriving from a social context, from political context, And we try to map the ICT power and the ICT potential to these objectives. Some of them are related to European Union integration, some of them are related to a better governance, but some of them are related to make the life of our citizens more comfortable, more efficient. And this means developing and putting in place a set of services which will make it possible for the citizens to be served from their offices, from their homes, and not going to a physical counters. So, starting from these generic objectives, we developed a strategic program which states that by the 2020 we have to have all e-services implemented and all physical services have to have their electronic counterpart. So in this time frame, we'll have to deliver almost yearly 10 to 12 services, and at the same time we'll have to digitize the back offices as being one of the preconditions of delivering these services. Again, 7 to 8 back offices digitized earlier. And we hope by that time we will have a 50% or more adoption of electronic services. So this is how we want to change our service delivery model. So this is how we want to change the life of our citizens. In this context, we elaborated a quite complex service delivery model. We are still working on improving it, which will contain how exactly and what kind of services we will put in place first, how we identify them, how we plan for them, how we budget them, and so on and so forth. As well, we intended to develop a service maturity model which will will allow us to have a picture of our e-services landscape, which of them are informational, which of them are more advanced, transactional, interactional, or even integrated. All good. Do we have the right platform to host these services? And the answer for Moldova, for now, is no. And that's why we started to think on the that modernized platform. We started to look at the technologies we have now. And from John's presentation earlier, we found that from those assessments, we found that there is a lot of potential regarding involving ICT and cloud computing in our case. What we want from this new platform? First of all, we want it to be modern. We don't want to stick to technologies of the 20th century, since we are in the 21st. We want it to be cost efficient, as well as modular, to be possible to reuse and to apply whatever changes we want to apply seamlessly. We want it to be simple, to increase the adoption, at the same time to be accessible, to allow citizens through different means to access services hosted in this platform. Also, we want to promote reuse, since this relates directly to these public expenditures, and we want to save public money at the same time. And our answer to these challenges and to these principles is mCloud. So John mentioned mCloud stands for Moldova Cloud. And this is literally transposing this to the cloud computing terminology. This is a private cloud, this is a government private cloud, which will be serving, first of all common cloud services such as infrastructure as a service, platform as a service, software as a service. At the same time, a lot of business services will be hosted there, and this will be, in fact, the first choice for hosting e-services for both for citizens and government itself. Why cloud computing? Cloud computing is on the agenda of each chief information officer, on the agenda of each chief technology officer, chief security officer, chief financial officer, after all. So it's because it's not so much of technical innovations and changes it brings to you, but it's how the services gets delivered. And this is exact response to our, for us looking for efficiency and security and improvements in service delivery. So I will skip this theory, I guess, for now, but this means this diagram reflects how complex is these different layers of the cloud computing. So this is theory, but this is what we want to implement in practice. And from this diagram, you will see easily what we want to put in place at the infrastructure layer, what we envision as being our platform as a service layer, and what we want to host at the software as a service layer. So first of all, we identify several services. So we have a set of sectorial services which will be developed by each particular service of the economy, sector of the economy. We're talking about health services, social protection services, education services, police services, and so on and so forth. The second group of services is the services which aims to make the government more efficient. So this is the primary users of these services will be public officers in the government. Since we are talking here about document and record management system, about business intelligence toolset for decision making, we are talking about a geospatial geoinformational system which will allow us to map data, analytical data to some geographical locations, and so on and so forth. So we have the third group of services which we call platform level services or common services, which are elementary services used almost by any of the sectorial services. Here we have authentication and access control, we have payment, since most of the services will be delivered for a particular fee, and we have notification and journaling. We want at the same time to bring with this new architecture some best practices from software development and from software architecture. After this X-raying the services landscape, we identified that a lot of services are monolithic. In this case, you cannot extend them as we want. So at least we want to adopt e-services reference architecture consisting of several layers. We want these services to not stay isolated anymore. So they have to get integrated into a interoperability framework. So from now on, each service will have to have the same functionality which is available for human users to have this functionality available through web services for different other applications willing to use the first one. And at the same time, we want to keep our eyes on how we evolve and how we collect the data about our public sector. So we want each information system to have a set of monitoring APIs, application programming interface, which will allow us to automatically collect the data from business data from these information systems and reflect it onto a dashboard. So this is our view on the interoperability framework, and here you may notice the sectorial services, shared services used across all ministries, the dashboard collecting and reflecting situation regarding the business key performance indicators in the public sector, the portal delivering these services. At the bottom, we have those elementary services or platform level services, and we have a mechanism of orchestrating all these business services by creating complex business processes. So this is the typical interoperability case, and it's quite similar with what Estonia has. We adjusted it a little bit to take into consideration our circumstances, our reality. Another innovation we want to bring with this new infrastructure is how we build platform-level services like payment, like authentication, access control. We want all of them to be developed using provider model, what we call provider model, or an architectural pattern provider. So this means that the same service could be delivered by different providers, and let the citizen to choose what is the best service, what is the best provider to be served in a particular case. And this brings flexibility, this brings neutrality, since we are equally distant from different providers. So this brings what is very important, cost efficiency, because different providers may compete on prices and on different level of quality. At the same time, it improves the maintainability, availability of the system as a whole, because if one provider fails, still other providers remain functioning. So transposed to e-payment or to electronic payments, this would look like something which is represented in this diagram. So this government e-payment gateway implemented as a provider, so you see the provider pattern here, is universal enough to accept payments from every service and to use every financial vehicle available on the market today. So this is something citizens will like, and the citizen will be that authority which will decide what kind of payment method he or she will like to use in particular context. So we told you about why we need this, what we exactly need, and now in a couple of slides I will present how we want this to be implemented. So we see this mCloud platform implemented incrementally in several phases. In the first phase, the procurement we launched already is intended to establish a platform where we will prototype every concept we have in mind today. At the later stage, we will extend our mCloud to a nationwide and full-scale cloud solution with data center consolidation coming afterwards. So in the first phase, we want to use the same facility we have today as a data center, and we will locate our cloud equipment in the same facility, and we will reuse the same data center infrastructure we have today. So it's not too much of capital investment in building and in building a separate data center for now. So it's we will make sure that the entry point is quite affordable. But what we want to prototype now is all cloud-specific services, disaster recovery scenarios, virtual desktop infrastructure scenarios. We want to connect local public authorities just to make sure that this is available for local authorities as well. We want to perform some exercises regarding data center consolidation at the same time. On the next phase, the cloud phase 2, which will start in the middle of next year, we want to extend the capacity of mCloud by adding new hardware, new servers, new storage. At the same time, we want to build a brand new data center using a public-private partnership model. We are partnering with some mobile operators, local mobile operators, to co-locate this new data center, and we are partnering with some of multinationals willing to make their presence in our region. So after we put in place the mCloud, we will start the data center consolidation exercise, which will give us the possibility to reduce the number of more than 100 data centers today to 7 to 10 high-performance data centers at that particular time. One thing I would like to mention how we see the transition to this new technology. Since this is quite new technology and it may put some risks on different institutions, on different teams, we want, as a part of our procurement, we procured 6 months of managed services where the vendor, the solution provider, is in charge of every change made to the system. And we will back up our people, so we will back up them with our people, so each of the cloud architect or cloud developer from vendor will have its own counterpart from our side. At a later stage, we asked for another 30 months of warranty period, and in this case, our people will be the main service operators. And after this period, business as usual, just our team working and operating all the cloud services. We want to move to dump terminals or virtual desktop infrastructure, and this is the last initiative listed here, but this is not, this is the technical part of things. Of course, there are a lot of legislation adjustments and improvements going in parallel, and the cloud first policy adoption, and many other interesting things. And this is the message I was willing to tell you today. Thank you very much.
Thank you. That's fantastic. That's great to see what's actually happening.
Thank you.
The legal part.
Yeah.
Okay, ready?
So yeah, if I could get my slides.
Fantastic. And back to Estonia again.
All right, my name is Mihkel Miidla. I work here in Tallinn, Estonia, in a law firm called Sorainen. I'm an attorney at law, and I specialize in IT law, data protection, and electronic communications law. Just a quick word about Sorainen is the leading law firm in the region. We operate in 4 jurisdictions, which means we have quite an extensive experience base working both with the private sector and the public sector, advising both of them, but not in the same cases, of course. And today I was asked to summarize some of the potential legal issues that are related to governments using cloud services. What I'm about to say is largely irrelevant in case of private government clouds, as Yuri was telling, but this is more relevant to situations where the public sector wants to use sort of like private sector providers for using cloud services. And the categories I want to briefly touch upon, because I understand the time is rather limited, are listed as follows. First of all, data privacy and security, then a little bit about contracts and liability, and then compliance. Compliance meaning what a public sector authority would have to take into consideration before using cloud services. And of course, the purpose is more to encourage discussion rather than to give an exhaustive overview. Moving on, first of all, the big question that always pops up has to do with data location and ownership, because once data is in the cloud, it does not recognize the state borders. Which engineers think is a good thing. Lawyers tend not to agree yet. And the practical issues and the questions that come to mind is of course in which country is the data stored, who has access to it, and then this all boils down to actually the issue of jurisdiction, and then also perhaps some national security interests, which another issue. I don't want to go into details there, but why is jurisdiction important is first of all, whenever data is pushed into a foreign jurisdiction, the requirements of that jurisdiction will have to be taken into account. And nowhere is it more visible, for example, than in intellectual property. What happens to intellectual property that you are putting on the cloud? Is the host state, does it have a clear enough legal framework to protect that data, your works? What happens to new intellectual property that is created within the cloud, that is hosted in another jurisdiction? Will you be owning that data, or will it become co-owned with the state X? These are just some of the questions that should be considered. Right now, especially bringing Estonia as an example, and of course the European Union, we have a quite a severe issue with cross-border data transfers, especially if data is to be transferred outside of the European Union or the European Economic Area, or to countries which do not have an adequate protection of adequate level of protection of personal adequate levels of personal data protection. I'm sorry, and why is this important? Is currently the process is very difficult in getting, for example, acceptance from national data protection authorities to get authorizations to transfer personal data out of the jurisdiction, and the problem becomes even more complicated because even in a closed system like the European Union, each member state has implemented the directive differently, and it will be a nightmare if you have you're offering the services in Estonia, you have the data center, the primary data center in the UK, and you maybe have some redundancy servers in France, so you're quickly faced with several jurisdictions and all of these issues that are quite complex and then do not have a uniform answer. And of course, whenever you are the data controller as the state, you'd have to ensure that your service provider meets the same requirements that you have to meet. So moving along, a little bit on the contracts and liability. This is just a sample list of possible issues that you'd have to cover in a contract where you want to procure services from cloud providers. What I want to highlight here is two things. One that should be considered is data handling when your service provider goes bankrupt. What will happen to the data? You'd have to ensure that you'll be able to get your data out, that your data and your IP doesn't form part of the bankruptcy estate, issues like that. And always you need to have an exit strategy, or you need to have the data portable, in other words. Moving on to the more difficult questions, what I would see is as the primary questions. First of all, is the liability issues. The service provider, the cloud service providers, will almost always want to limit or even exclude their liability, whereas you, as the client, want the liability of the service provider to be as high as possible. We've heard of examples, for example, in I guess it was the city of LA who contracted with Google, and in an unprecedented case managed to obtain uncapped liability from Google, which makes the decision making on part of the government much easier. So if your service provider accepts uncapped liability, you're in a much better position.
How do you apply it?
Sorry?
No, it's okay. I was commenting.
And the other issue you'd have to follow is your own liabilities. So some of the service providers will almost certainly, besides you having to pay the bills, will put other obligations upon you. For example, making sure that you have the right legal basis to process, for example, the private data that you put in the cloud. A very important question is, and needs to be determined, that who is your actual service provider, because in the market there are a lot of mid players, persons who intermediate the cloud services and are building their own value-added services on the, for example, the infrastructure they're buying from Google. What is there to, for example, on the next day switch to another service provider located, for example, in China, who offers them a better price? You as the end client do not have any right to say to your service provider what kind of infrastructure he can use. So couple of solutions here is to sort of ask the final cloud provider to join in on the contract, or again be very specific on the locations where the data may be hosted, and also make the service provider clearly liable for any mistakes or shortfalls that the cloud provider has made. And we come to the classic, really difficult point with any civil contract is the enforceability. For example, the services are provided in Estonia, but there obviously can and will happen some problems. It will be very expensive to go to courts in California and have this judgment or arbiter award recognized here, and not mentioning that it takes a lot of time, it's very expensive. And as the third block, quickly moving through these, is as a government agency buying cloud services, you'd have to be compliant with the legal framework that is set upon you. For example, these are just a few highlights. The national rules for archiving, interoperability with other e-government services. For example, I believe Estonia has a rule that once there is some data in the government databases, it's kind of not nice or almost illegal to ask the citizens this information twice. So you can you need to make sure that you can recycle this data also in some of the services you may have cloud-based. One of the more difficult issues is the requirements of public procurement, and these I believe are issues that at least on an European level will at some point even start making it difficult for countries to implement private government clouds, because it restricts the market. And you have to take into consideration the competition rules, the freedom of the free movement of services, and your tender documents must be brilliant, because it's very difficult to change anything afterwards. And I guess in conclusion, what I wanted to say is that whenever you're planning to procure cloud services, you need to chart all the legal risks, give it full thought and analysis, and weigh these risks against the benefits that can be achieved. So thank you very much.
Thank you. That's a fantastic checklist of things to discuss there. Okay, rather, I was so tempted to abuse my position as moderator and ask a question, but I won't. I will resist it.
Later.
Yes, thank you. So, again, are we going to get another Austrian perspective?
Yeah.
Okay, this is fantastic.
Thanks.
Another for those of you who were here this morning, obviously. Otherwise, this is completely fresh.
I won't tell you exactly the same things I talked about in the morning, so not too much duplication. No, in fact, I can be very brief, because the advantage of being the last one in the row is that I can pick and choose those points which had not been mentioned before. So I really can save you the time for more discussion than afterwards. That would have. This is exactly the wrong I have another presentation. Otherwise, I do the same like in the morning, but that's what you wanted to exclude.
Are they going to find your...
No? There is a second one on cloud. Then we have a longer discussion. Huh?
sorry? Does your cloud presentation contain any excellent pictures and stuff?
Attorney.
Give them your. Give them the USB.
So I put the USB stick there, and we have one round of questions in between. Huh?
Okay, we could do that.
Microphone is on.
So,
dictate.
in stark
Let's
contrast
dictate.
to this morning, I haven't received a
Let's
welter
dictate.
of tweets.
Microphone is on.
So, while we're waiting for Peter's Austrian experience to appear, and it will be fantastic and worthwhile, would one or more people like to ask questions? In fact, we can move the whole panel, I think, to the facing side of the chairs. Aha! Fantastic. Thanks, Steve.
So I've been listening with interest to the presentations, and one of the things that I've been hearing, not just in the presentations, but as I speak with other people at the conference, there seems to be at least an initial step, sort of maybe V1 to the cloud. Sounds a lot like private government cloud. I've seen that come out in a few presentations. And my question is, I'm curious about how I had the one slide in my presentation yesterday that showed as you got to larger and larger aggregations of servers, the costs, benefits, basically economies of scale dropping very rapidly. How does that additional cost savings play in? Do you think that private cloud is a first step for governments to get comfortable, and then maybe public cloud will come? Or wondering if anybody has any ideas on that one.
No? Okay, right. I didn't notice that. Okay, so first of all, when people present to me the cloud as the miracle for the economies of the future, I usually make two reflections. First of all, despite the volume of the infrastructure cost, if you look at, in our case, to the total cost of ownership of our application, still infrastructure is a very low percentage of the total cost of ownership. You develop, you spend much more on development and more particularly in maintenance for long-term projects. That's one thing. So it's just to put the amounts in context. Still, we need to reduce. But in governments, more particularly, just consolidating and standardizing and eliminating, you gain about 70% of the cost of the future cloud. And then you have the potential to do more. In my place, I had the chance to run two services. One is a more policy-oriented, that is ISA program, that is concentrating on dialogue with member states about how we can better interoperate and deploy cross-border services, and then running the internal IT. We have about 72 computer rooms. We have about 3,000 servers. If I take the number of users, 35,000, and I just brutally divide that by 3,000, means that every user, every server will be serving 10 users. It's not like that happens. I mean, there are potential for savings enormously. So this is the first thing. So before going in a disorganized way to the cloud, it's better to do your homework and then from there. And I believe that one of the slides that you propose is in the same. So prepare yourself for the cloud and use the cloud as an additional sourcing method. The legal issues that have been presented are very scary. I mean, why the hell you have the safe harbor, but you have the Patriot Act? So people, governments are scared about that. And if you have diversified legislation on how to protect, and then you know that when the jurisdiction in your country, you are going to spend a lot of money, and you never know whether even with uncapped kind of liabilities, and you are going to succeed. That means that prudency is the first step. And you guys, the security guys, you will never go to the cloud. That's for sure, for sure. But there are opportunities for the cloud. Simply you need to select your low-hanging fruits. For instance, in Spain, I heard that the guys that are in charge of all the traffic, when they have snow, for instance, they cannot support that all the access on their servers. This is public information. Why don't you put that into the cloud? There are plenty of sites that are going to disseminate policy in the European Union that have a lot of traffic during the peak that is happening over the first month, and then goes away. So you have to use the elasticity of the cloud in the best possible way for targeted use. And will we have a full public cloud strategy in public administration? I don't think so. That will always be, in my opinion, hybrid. Look at any other kind of government services and you will see that, except in some countries that are taking that to the stream, the tradition of the bureaucratic kind of approach to government in Europe means that you keep a lot of tight control on the services and you really completely outsource. I mean the low value kind of services. This is my view on that.
Okay. I think what we might do is, unless not, we might move to Peter's presentation on cloud
we
computing.
move over there.
No, you could. You can stay there. That would be fine. Okay, Peter Kuster.
Okay, thanks. So I'll restrict myself to only the points which are still missing. That would have been the whole program, but I'm not doing that one. The general characteristics we heard already and the definition, so I won't go into that. For me, one sentence is crucial, that cloud computing itself, it's not a technology, but mainly a business model for providing IT services with, of course, additional considerations. We see opportunities and risks which are to be seen from the legal, structural, economical and technical side. The legal aspects, most of them we already heard, and I can congratulate Mikkel for the overview before, because it was a very good overview on most of the crucial issues we have there. So for us it's quite clear that for a public cloud, personal data processing will not be the real option to choose. Contractual adjustments are almost impossible to enforce there for public cloud. Virtual private cloud may be a bit easier to go to for the private cloud. The conditions seem to be best ones to meet data protection requirements. Nonetheless, there are still issues you have to consider there. So for non-personal data, and that's what Paco said right now, there is no reason not to choose cloud from this perspective, so for public information. And so nonetheless the contractual issues are there, and the procurement issues are still there, because even if we talk about non-personal data and public cloud, the question arises how a real procurement procedure may take place. I mean, that's if I release a tender, I'm not quite sure whether Amazon and Google really will approach me, and what are the licensing behind that, models behind that, and all that, retention issues, and so we have lots of questions there. For the structural aspect, one thing I wanted to mention is there is a certain risk, of course, of creating a silo solution by choosing ad hoc cloud computing model. And of course, the exchange of data between applications may be quite cumbersome. The economic aspects we heard most of them already. So there is a shift between running costs and investment costs. Technical aspects, standardization, I won't repeat that. We had that in much detail. Scalability, identity and rights management, of course, privileged user accounts, administrator accounts, especially in the combination of cloud, is a very sensitive issue. So the pure user ID password managed administrator for a cloud-based service may raise interesting questions. Patch management, technical revision, and so on. So we had some of those. I wanted to mention the question of EID and cloud. So do we have something new there? As I said before, it's not a really new technology, but the combination and the scale and all those aspects before bring may bring the breakthrough for this cloud tendency. And the EID question is, we have a real change in the basic assumption, because we in our minds we have still a client-server model based on end-to-end security and so on. So this is not longer possible with cloud, because there is a third player in between there. It's client, cloud, server. And with this, the whole assumption changes, which then has legal consequences, contractual consequences, and so on. So this is really the shift in paradigms we face here. So for EID issues, cloud will be a specific challenge from all that. And the question is whether crypto-based technologies, security issues will need some rethinking for cloud issues. Just think about, there is no physical control by the user on what's going on there and so on. So what we think about in Austria is to create cloud compatible applications and developments we have there. For that, maybe both ends need some twist, the EID domain as well as the cloud domain for that. How will we proceed in Austria? We now go into piloting and analyzing cloud projects on a smaller scale, so to say. So we are analyzing all the aspects, especially the legal aspects, organizational aspects, in very much detail. We had, since last year, a working group looking in all the details, and now we are experimenting a little bit. What we set up here is an EID, single sign-on cloud service, where we experiment on how to assure there for the adequate security issues and personal data privacy considerations. New applications we develop should be developed in a way that they would be cloud ready, so to say. That is the way we would like to go to. Of course, we need suitability criteria for the cloud itself, which model may fit into what kind of application, into what kind of implementation. And the cloud standards, we talked about that before. Of course, the European considerations are crucial here. Well, that more or less closes things we are testing, piloting, evaluating, and we are quite confident that we can exchange in a quite good manner on the European considerations for the EU cloud strategy. Thanks.
Thank you. Okay, we have time for a couple of questions. Well, at least one. Somebody from the audience. Cloud? EID? Shh.
Okay, my question goes to maybe head of IT in EU. I think one of the characteristics of cloud computing is consolidating all the resources. I think we have a good presentation from Moldova and also Austria and some other country cases. But when you think of EU, your big target is make a single market, like a single country. Then, have you ever think about this cloud computing for EU as a provision to many small countries in EU, which is not enough budget, not enough capacity of people like that?
Okay, probably because I didn't have the time, I didn't clarify a number of issues. So I am just to put my position that is related to the reply to the questions. So people say to me, I'm the Director General of IT for the European Commission. So people say, okay. So you run the IT or you supervise the IT for the member states in the European Commission. The answer is no. Then the next question is, you supervise the IT for all the European institutions. The answer is no. The good news is that I work a lot with member states and I work a lot with other institutions so that we work in synergy. So this is the first part. So I don't have any power on anything related to consolidating at the European level any infrastructure. I don't even have the power in my institution, but I have the influence because I don't like power. I like credentials and influence. And I believe that with that you achieve much more than in power, more particularly in public administration. So IT is an exclusive competence of member states. So the EU doesn't have a lot to say, except if any use of IT might represent a barrier to the development of the internal market. And it happens sometimes to be so, and that's why some of our major programs have the development of the internal market as the legal base. Governments are so big and have such a capacity of purchasing that if they disrupt by electronic means the free circulation of goods and services, they may put in danger the internal market. And this is the only hook where we can say something to member states. So there will be ever kind of government cloud even for a set of countries. Generally speaking, no. May it happen that for some specific systems, we, as an organization, the European Commission, may take over some of the systems, giving them putting in place the appropriate governance and giving them the adequate quality of service. Yes, and I have a very recent example. There was what we call the Kyoto database. The Kyoto database was to the change of CO2 quotas, pollution quotas. There were a distributed kind of system where there were registries on every country, and there was a central one in the European Commission and another one in the United Nations. It happened also a few months ago that this site was attacked and hacked with SQL injection. The result of the matter is that all the change of quotas was stopped. In the meantime, already member states said, why the hell we should develop one system whereas a central system could do better, faster, and be more secure. And we were planning for that. And now we are in the middle of the planning because we are going to deliver this specific system that's going to connect with the one in the United Nations on the 1st of January of 2012. So punctually, it may happen that we run system on them, and whether we run it on the cloud, on our premises, it doesn't matter. This is just a sourcing mechanism. What is important is what kind of guarantees and level of services we are going to give to member states for this specific system. So, for the general thing, no. For a number of things, yes.
Great. Thank you. A comprehensive answer. Okay, we have time for another question. Oh. Okay, Steve.
If no one else. No, I mean, I think after I ask this question, everybody's going to come beat me up because of my belaboring points about public cloud. But I'm doing this as much to sort of as a thought-provoking exercise. Based on all of the discussion we've had about cloud here so far, when we start talking about public cloud, it seems like there's a fairly common reaction, which is, whoa, there are a bunch of privacy and sovereignty questions. Those are all really big. Somebody's got to go figure those out. Let's move on. And what I've heard that makes a lot of sense here today is the notion of, well, there's data center consolidation. Your answer was really what I was looking for, which is there's a whole bunch of work that cloud can be a forcing function for data center consolidation. And my parting question really is around these privacy and sovereignty questions. And I'm curious if there aren't some that might just be things that we have to work out through various ways of getting a better alignment of national laws, but others that we may just have to learn to be comfortable with. And on that, you mentioned the Patriot Act. I was having dinner with some folks, and I mentioned that, well, most countries actually have a terrorism-related mechanism for getting at pretty much any data. And so the Patriot Act, rather than being a sort of a exception, is kind of a rule. And so I wonder if we know that there's something like that in pretty much every jurisdiction, are some of those ones that will we get over them or never get over those? Is that potentially just a huge impediment to public cloud?
You're all wearing headsets.
Well, I guess
okay, excuse me again.
One of the
No, I tend to forget.
the potential solutions could be, and you're of course right that each and every country has similar acts to combat serious organized crime and whatnot. Is to use very sophisticated encryption technologies, for example, to at least secure some of this data. Some personal data could be pseudonymized in a way that it is not personal data anymore, at least while it's in the cloud, and sort of like translated backwards when it's back in the originating country. These are perhaps some of the solutions technology-wise. From the legal perspective, I guess it's quite certain that the counter-terrorism laws will not go anywhere.
I just wanted to add that, again, this is a more a legal organizational issue than a technical issue. But the reality is that you need to carry out some kind of risk analysis of all your information. And based on that, I mean, the best way of not solving a problem is trying to generalize and globalize the problem. So I like to approach the problem on at least we agree on what we agree, and we agree on what we disagree, and we work on the disagreements. If we approach that this way, probably we are going to get openings there. But the first thing we need in terms of, because privacy, more even than security as such, privacy seems to be one of the major barriers. I was in that meeting I mentioned before on the first week of September, and what the Director General of Information Society asked to the guys in Justice is, at least do not reject the possibilities from the beginning. I mean, give us some opening so that we can continue studying the thing. Of course, this is at the level of the European Commission. I wanted to also to destroy another myth, is that Brussels decide everything. So I didn't have the time to display a very interesting slide I have about the EU policies and the competence. And if you look at the competence in the European Union, there are 7. The rest are shared competencies and a lot of support actions. So at the end of the day, even if we have some competencies, in this area we have very few. It's our member states, and at the end of the day, this is agreed by member states. So even when we make the most convenient or friendly proposal to the cloud computing in terms of privacy, still the Parliament and the Council that are representing the citizens and the member states may completely go the way around. And just to add, the Lisbon Treaty was supposed to simplify the things. Well, I can tell you that now the process will be longer, and whatever kind of non-fast track initiative is going to take about 2 years. So, did I reply to your questions?
Yes.
You did. I would like to add one thing. I know we're running out of time, but my own question to John and to Peter, and also Mikhail as well, yeah. Because certainly, Peter, on your slide, when you came to the legal side of things, it was all minuses. And we almost had that from the legal perspective as well. And yet, from what I've seen in the UK, everything's changing. There's a lot more data. It's not just the existing personal data. We're getting a much richer data sets being, particularly in e-health, collected. And we can't afford to meet if we want to innovate like this, if we want to take the science forward, if we want to take the social innovation there, we can't afford to do it properly if we have to maintain it on little boxes underneath every scientist or epidemiologist or developer's desk. Yeah. So we actually, to some extent, need this. I mean, do you not think that we will be, as well as being frightened, by the legal implications, we will be driven by the legal implications of the new things that we're doing towards this? Or is that a naive view?
Yeah. Well, to start with just a sentence, yes, there had been quite a few minuses for the legal perspective. That might also have something to do with my profession, because I'm a lawyer. Nonetheless, I'm not frightened of the legal issues, but I really see that as quite a challenge, how to meet the proper requirements on the legal side and at the same time reach what we are aiming at with this solution. And the twist has to be on several sides. It might have to be on amending the legal framework, but we have to be aware of the fact that we still have very different legal traditions and cultures within Europe itself, and of course in comparison with other countries in the world. And I'm not quite convinced what has been said before, that all countries might have something like a Patriot Act and things like that. I don't think that you would be able to really compare those counterterrorism legal frameworks between all those states, and I doubt whether you will find too many EU countries really having the same standards and levels we see on the US side. So that's one thing. The other thing is, yes, what has been said before by Mikhail, things like pseudonymization, things like cryptology and so on might add to the level of security and might reduce therefore the risks for privacy and data protection, might therefore be a solution or kind of solution for making it happen, cloud and even personal data. But we really have to study that. It's not that we say no, stop cloud thinking, but it is here. Cloud is here, and we have to see that this is a way to go to. So we have to find appropriate answers for those questions we see right at the moment. Huh?
Well, I would like to approach this or answer this in a very philosophical way, because all in all, anything new is and how to deal with it boils down to basically values that the society under consideration holds dear. and whether it is at some point the protection of the individual, their privacy, or it is the progress of the society and perhaps the public interests and innovation, and they are with the cloud they are clearly moving in different directions. So it boils down to the values which are reflected in the laws. So it takes time for the values to be reflected in the laws to meet up with the way life is going. What I want to say is it's just a question of time. If the society's values really have changed.
John, final word?
Real quick, as an engineer, we think in two different ways. We think in one level that we want to be creative, all the things that we learned and we can dream about and put on a whiteboard. That's one way that engineers think. And the other way that engineers think is that we solve problems. And what we want to know from regulators and what we want to know from governments or regional political bodies is, what is your objective? Give us your objective and we will go out and design a solution that meets your requirements. And that's what engineers want to do. And with cloud computing, if you set a law, if you set a legal framework, we will find a way to develop the technology to fall within that framework.
Maybe you shouldn't. Maybe you should drive progress.
Okay, fantastic. Well, thank you. That philosophy can continue through the coffee break and right into the pirate party, actually, at 4:30. So open government at 4:30. Clearly, enjoy your coffee. Thanks very, very much to the presenters.
Thank you.